we are here to present our neural network final project, that is question duplicacy detection. The motivation behind our problem statement is that there are numerous number of questions floating around on different kind of forms on internet, but we know that many questions are similar to each other or even duplicate. So we need a concrete way to find out which questions are duplicate, which will make our search faster. So we have focused on developing a machine learning model which can detect duplicate questions and which can therefore result in faster search time. We took a open data set from Kaggle, which is based on duplicate question pairs from Quora. We had 37,000 duplicate questions and 62,000 non-duplicate questions. The column is duplicate represents whether the question pair presented in the dataset is duplicate or not. In the data pre-processing part, we converted all the sentences to the lowercase, and we also removed all the stop words using the NLTK library. We also applied stemming to each word to convert it into its corresponding stem word. We also removed some special characters like @ and hash. We used a training and test split of 80 to 20%. As our baseline approach, we used logistic regression classifier. As an input to logistic regression classifier, we concatenated the two questions and inputted into our model. After training, we achieved an F1 score of 0.61 and an accuracy of 73%. This was okay-ish as we were trying to get a reasonably higher score, but this was good as per our baseline approach. To improve on our baseline model, we used Siamese network architecture. We used Siamese network with LSTM model, so it consists of shared weights between the LSTM models. To compute the representation of each question, we take the last time step of the LSTM network. After passing both the questions into the LSTM network, we get two different representations for each question. To compare those representations, we use Manhattan distance. Manhattan distance gives us a value between 0 to 1. To classify it, we use a threshold of 0.5. That is, if the Manhattan distance between the two output vectors is greater than 0.5, then we classify the question pair as duplicate. The following were the hyperparameters that were chosen after the hyperparameter tuning. The number of LSTM layers were 2 and the number of epochs were 8. Also, the learning rate was 0.001 and the optimizer used was Adam. Coming to the results, we can see that the accuracy was 77% and the macro average F1 score came out to be 0.76. We can also see from the training curve that validation loss was not decreasing, which means that the model was not able to generalize well on the unseen dataset. But the accuracy and F1 score definitely improved on the baseline model. Next, we tried cross encoders, which is a transformer based approach. It uses BERT as its base and takes two sentences as an input, which are separated by SEP token. After calculating the embeddings from the BERT model, we use an average pooling layer to compute the sentence embedding, and then we use a softmax classifier to classify the output. As a brief introduction of encoder layer, it consists of multi-headed self-attention and feed-forward layers connected with some skip connections and some normalization layers. Let's talk a little bit about self-attention. The self-attention calculates attention of each word, how much attention each word should pay on every other word in the sentence, and calculate attention-based representation, which takes into account the context of every other word as well. To calculate the attention, we have the formula as mentioned here in the slide. The next is the hyperparameter tuning for cross encoders. We did a lot of hyperparameter tuning, so the number of we tried different epochs, batch size, learning rate, and different optimizers. After a grid search on these hyperparameters, we found that 4 epochs and batch size of 16 with learning rate of 0.001 and Adam optimizer works best for our case. As we can see, the validation loss is also decreasing quite smoothly as compared to the training loss. Also, the F1 score was 0.85 and accuracy was 87%, which was quite better than the other two approaches. We can see that the F1 score of cross encoder increased by 15% as compared to Siamese network and 21% as compared to our baseline model. We can also see that the model is also able to generalize well on the unseen data, as we can see that the validation loss is also decreasing continuously. In conclusion, out of the three approaches we have used, cross encoders performs the best. The reason for this is cross encoders uses self-attention, which calculates attention each word should pay to its context words, based on which the representation is calculated. The Siamese network, which is based on simple LSTM, is not able to do attention mechanism, and hence the cross encoders performs best with F1 score of 0.85. Thank you.